So, पार्शियल डिफरेंशियल इक्वेशन के हम लोग काफी लास्ट में आ गए हैं एंड वन इम्पॉर्टेंट इक्वेशन इज स्टिल लेफ्ट एंड दैट इक्वेशन इज you know Laplace equation. That Laplace equation may be also considered as heat equation in a steady state. Let me explain you how. So I am going to discuss now the Laplace equation. Okay, so this Laplace equation can also be considered as uh, steady state heat equation. How can I do that? Suppose I wrote c square and I write heat equation in two dimensions, so it will become uxx into u plus uyy, and that is equal to u of t. Correct? In one dimension it was c square uxx is equal to ut. In two dimension it will become c square of uxx plus uyy. In 3D it will become uzz also. Correct? So this is the Laplace equation in two dimension, and if I take steady state solution, so this is heat equation actually, heat equation in 2D, and if I take steady state, it will become u of xx plus u of yy is equal to 0, because steady state means del by del t will go to 0, nothing is changing with respect to time. So this will become a two-dimensional Laplace equation. This will become a two-dimensional Laplace equation. So you know that Laplace equation is very important equation, and it is used in mechanical engineering, it is used in our electrodynamics, electrostatistics, okay, to solve the potential. So we use Laplace equation. So let us try to find out the solutions of this equation, the two-dimensional Laplace equation. Correct? So the method will be exactly same. So we will have u of xx plus u of yy is equal to 0. This is the Laplace equation, and u of x comma y will be given by capital XX into capital YY. Okay, so the same variable separable technique is also used to solve the hydrogen atom problem. Same technique. Okay, so like if you have three variables, so size depending on r, theta and phi, so you will write capital R as a function of small r, capital theta as a function of small theta, and capital phi as a function of small phi. Same technique is used. So this is capital X x into capital Y y, and now put this, it will become y of x double dash plus x of y double dash is equal to 0. So it will become x double dash by x is equal to minus y double dash by y. Please see this. ये तो टेक्निक क्लियर है सबको? बताओ भाई.
Yes, sir.
Yes, sir.
So this I will write now is equal to some lambda square. Now there is no point in writing minus lambda square, because you know if I write minus, then this will become plus and this will become minus. So ultimately एक को तो minus होना ही पड़ेगा ना? So that's why there is no benefit of that. So I will write two different equation. Minus lambda square x is equal to 0 and y double dash plus lambda square y is equal to 0. So capital X will become c1 e to the power lambda x plus c2 e to the power uh, minus lambda x, correct? And capital Y will become a cos of lambda x plus b sine of lambda y. Sorry. So these are the two solutions, and now comfortably you can write u of x y is equal to uh, c1 e to the power lambda x plus c2 e to the power minus lambda x into a cos lambda y plus b sine lambda y. So this is the solution of the Laplace equation. Now you can see there are four constants, so you need four boundary conditions to solve it. Four boundary condition to solve it. Okay, so this will also become a problem of electrostatics, solution of this Laplace equation, and this will also become equation of heat when we are looking the heat equation in a steady state. Okay, so both problems can be considered. So now let me take a problem. यहाँ तक कोई डाउट तो नहीं किसी को? Is this perfect? Anything you want to ask? So now let me take a question in which the region is given like this. This is the region in the xy plane, and the potential here, here, here is equal to 0, and the potential here is given as some function of y. This is the question. Okay, that you have a region in which this is grounded, this is grounded, this is grounded, potential is 0, and this side you have a source which is giving you potential which is some function of y, fy, that can be changed and your question will be changing. और अगर इसी को हीट की प्रॉब्लम बनाऊं तो ये तीनों 0 डिग्री सेल्सियस के टच में है, इधर से कोई सोर्स है हीट का which is giving you fy. Okay, and this is 0 comma 0, this is a comma 0, this is a comma b, and this is 0 comma b. So that means the x goes from 0 to a and the y goes from 0 to b. Please see this. X goes from 0 to a and y goes from 0 to b. देखो समझ आ रहा है? So you understood the condition, the boundary condition that is given?
Yes, sir.
So now what we have to do is we have to apply these boundary conditions. Like first of all I will apply here. So it is u of xy is equal to, so what is this representing? This is let me name it. This is first, this is second, this is third, and this is fourth region in which we will apply the boundary condition. So first of all I am taking care of one. So this is uh, whole of this you know plate, the potential is 0. So that means potential is 0 at u is equal to 0 comma b, 0 comma y. प्लीज अंडरस्टैंड दिस. इस पूरे पूरे पॉइंट पे x की वैल्यू क्या होगी? 0 होगी. So this gives x of 0 into y of y is equal to 0. So this gives x of 0 is equal to 0. Correct?
Yes, sir.
Now second, What is this? This is u of, what is the value of y here? B. So ux comma b is 0. Correct? So x of x and y of b is equal to 0. So that means y of b is equal to 0. This is second boundary condition. After this, fourth, u of x comma 0 is equal to 0. That means y of 0 is 0. So these are the conditions. And finally, सबसे last में ये वाला apply करूंगा to calculate the fourth constant. Okay? Ask if there is any doubt in this. Clear hai? So let me apply the first one. X is equal to c1 e to the power lambda x plus c2 e to the power minus lambda x. So it will become 0 is equal to c1 plus c2. So that means c2 becomes minus c1. So that means the value of x becomes c1 e to the power lambda x minus e to the power minus lambda x. That means this becomes c1 sine of hyperbolic lambda x.
Sir, 2 sine hyperbolic
So
lambda.
2c1 is a constant, that I have again written c1.
Okay.
That will not make any difference. Okay. Now what? Y of y is equal to a cos lambda y plus b sine lambda y, and y of 0 is equal to 0. So 0 is equal to a. So that means y of y will become b sine lambda y. Is that okay? And then y of b is also 0. So 0 is equal to b into sine lambda b. So this gives me sine of lambda b is equal to 0. That means lambda b is equal to n pi. That means lambda is equal to n pi by b. Okay. So what is the value of y now? What is the value of y?
B sine
Pn sigma.
Y of y is equal to
B sine n pi by
bn sine of,
सिग्मा
अभी b ही रहने दो, अभी मैं सिग्मा फाइनली लगाऊंगा ना. So this will become sine of
n pi by b.
n pi by b into y. Okay, let me write b and no harm. So this is the value of y. Now यहाँ तक अगर बिल्कुल क्लियर है, so I will erase this and now I will write that u of x comma y will become, because I will have to take all the combinations, all linear combinations, so it will become this, and this will become some kn, no, this A has become 0 and B has become Bn. B will be multiplied to all these two. So it will become sum An e to the power n pi by bx plus bn e to the power n pi by bx into sine of n pi by by. Please see this.
Sir,
Hmm.
we calculated na a capital X of X is equal to C1 sine hyperbolic of.
Oh, that we have already calculated. Sorry, तभी तो मुझे लग रहा था कि क्या गड़बड़ हो रहा है. So
Yes, sir.
that we have already calculated. So that's why I can write kn and sine hyperbolic n pi by bx and sine n pi by by. So this is, my potential. See this. This is my potential. So now let me take a very simple case. सब कुछ ऐसा ही था and we can take the values of A and B, some values of A and B to see. And let me take that this Fy was very simple potential V naught. मान लो एक 5 वोल्ट की प्लेट थी. The plate was connected to a 5 volt potential. Correct? ठीक है ना? So what your ux comma y means, what is the potential at any point inside this region? इसके किसी भी पॉइंट x कॉमा y पे पोटेंशियल क्या होगा पूरे रीजन में. You can calculate potential at any point. Correct? So let us calculate how you will get this. So we will have to apply the next boundary condition to get the value of kn. Okay? So how that will be calculated? What is this? This is at x is equal to a. So this is v naught is equal to uh, summation n is equal to 0 to infinity kn and so I can calculate kn in advance first of all and then I will take a special case just to tell you. So this is Fy. So what is Fy is equal to? This will be equal to summation n is equal to 0 to infinity kn. The value of x is a here, so it will become sine of hyperbolic n pi a by b, and this value will become sine of n pi b y. So this is a constant, this is a constant, this is a variable. So to calculate the value of kn, I will again use Fourier half series. So this will become sine n pi by by, and this will become sine hyperbolic n pi a by b into sine square n pi by by. So this will give you 0 to b and dy, and this will also give you 0 to b and dy. So this will become upper limit by 2, so it will become kn sine hyperbolic n pi a by b into b by 2. So what will be the final value of this? Tell me. The kn will become 2 by b sine hyperbolic n pi a by b integral 0 to b f of y sine of n pi by by and dy. This is the value of kn. Correct? This is the value of Kn. Now please see what is going to happen. In a question, suppose Fy was V naught is equal to 5 volt. एक 5 volt का potential, constant potential यहाँ है, and we want to see what is the potential here. Correct? So what will happen? That value of Kn will be 2 times V naught will come outside, B sine hyperbolic n pi a by b integral 0 to b sine, what it will become, minus cos n pi by by over n pi by b and 0 to b. करेक्ट? सो देख लो मैथमेटिक्स आपको एकदम यही सेम टाइप ऑफ मैथमेटिक्स इज यूज्ड इन फुरियर सीरीज, फुरियर ट्रांसफॉर्मेशन. जस्ट आपको अपने आप को एनेबल करना है इस तरीके से. So this will become Kn is equal to 2V naught over B sine hyperbolic n pi a by b, and this is also n pi by b. So it will become b by n pi, correct? And minus sign will give minus taken common. So it will become, first of all put b, it will become minus 1 to the power n minus 1. So if I write it taking minus inside, I can write it 1 minus minus 1 to the power n. So that means for even values of n, it will become 0. So Kn will become, b से b cancel, 4V naught by sine hyperbolic 4V naught by n pi into 1 upon sine hyperbolic n pi a by b, where n is equal to 135 dash dash dash. That is the value of Kn. So now substitute the value of Kn in the equation, and that is the profile of the potential. So this is how the Laplace equation is taken care. Please see this. If you have any doubt in this, you can ask. So V नॉट को 5 वोल्ट रख दोगे और फिर इस Kn को वहां पे ux, y के साथ रख दोगे. So that infinite series will represent the solution of the potential in this region. So let us solve Laplace equation in polar coordinates, or you can call it as a steady state heat equation. This is the way how even Schrodinger equation is solved. So let me write the Laplace equation first, that is given by del square u is equal to 0, and now this time I want to write it in polar coordinates. So del square I will write of spherical polar, so that will be plus 1 by r ur plus 1 by r square u theta theta is equal to 0. So I am taking the azimuthal symmetry so that the phi component is not there. Okay. So this is the Laplace equation or steady state heat equation that I am going to discuss. Okay. So this is kind of 2 dimensions. So it will become ur comma theta is equal to, let me take as capital RR and capital theta theta. Correct. So substitute it here. It will become capital theta r double dash plus 1 by r capital theta r dash plus 1 by r square capital R phi theta double dash is equal to 0, and just separate them. First of all, divide the each and every term by this capital theta and R. So it will become, this is cancelled, this is cancelled, and this is cancelled. So it will become uh, R double dash by R plus 1 by R dash by R is equal to minus phi double dash by phi, and R square is here, so let us multiply it here, R square and R. So this has become a variable separable. So let us write here some lambda square. So two different equations are formed. The first equation is R square R double dash plus R dash minus lambda square R is equal to 0. And the second equation is phi double dash plus lambda square phi is equal to 0. So these are the two equations that are formed. So यही difficulty आती जाती है when you solve hydrogen atom problem in quantum mechanics. This part which depicts the radius, so that is a complicated equation to solve. That is not easy to solve. Sometimes that becomes Legendre in one case, sometimes it becomes Lagore, sometimes it becomes a Bessel's differential equation. So that is a complicated differential equation to solve. That is the problem. Okay, but here we will be able to solve them. It is not that tough. Let us try to solve. So I will write it properly. It will be R square del 2 R by del R2, just to make sure that you understand. Del R by del R minus lambda square R is equal to 0. Anybody can tell? कैसे solve करें इसको?
Euler equation.
Euler's equation.
Yes.
So this is Cauchy-Euler form अगर आपको नजर आ रहा हो तो R will be equal to e to the power z, and R d by dr will be equal to d by dz, will be equal to operator d. याद आया? Are you remembering? I told you in second order, last topic जो था, this was your last topic. So what it will become? It will become dd minus 1 plus d minus lambda square is equal to 0. And this will become d square minus d plus d minus lambda square is equal to 0. So this will cancel, and this will become d square minus lambda square is equal to 0. So d is plus minus lambda. So what is the value of R? That will become C1 e to the power lambda R plus C2 e to the power minus lambda R. Z, sorry, because our operator is now Z. And phi is very simple, I mean theta, that is A cos lambda theta plus B sine lambda theta. So what kind of solution we got? We got a solution like this: u of r comma theta is equal to and we have to write it in form of z is equal to log of r. So it will become c1 r to the power lambda plus c2 r to the power minus lambda into a cos lambda theta plus b sin lambda theta. This is the result. देखो जरा ध्यान से, if there is any doubt you can ask. Please check. I have substituted here z is equal to log of r. So log and exponential got cancelled. Is that okay for you? So now let us take a problem to understand what we have done and where we can apply this. So the question is, the problem is like this. There is a semicircular plate. The diameter of this plate is kept at 0 degrees Celsius and this is kept at T degrees Celsius. These are the boundary conditions, and it has got radius is equal to a, and we have to write the temperature at any point r comma theta. That is our question. In steady state, it is given in steady state. So steady state हीट इक्वेशन का मतलब क्या है? Laplace equation. Steady state heat equation means Laplace equation, and that can be applied to this. This is the solution of Laplace equation in polar coordinate. You can see it is a semicircular plate, so polar coordinates will help us. So what are the boundary condition with this? First one is u 0 comma theta is 0, because if you are at this point, that means this point will be at diameter which is in the contact of ice, suppose 0 degrees Celsius. Then u r comma 0 is also 0, because if angle is 0, so this is in general some u r comma theta, this is angle theta. So if theta becomes 0, then also you come to the diameter and u r comma pi will also be 0, and u a comma theta will be equal to capital T, which is given. So these are the boundary conditions according to the question. Please see, are you okay with the boundary conditions? Or if there is any confusion, you can ask. This one result, x0 is 0. This one result, capital theta 0 is 0. This will result capital theta pi is 0, and this will result, ये finally apply करेंगे, ये last में apply करेंगे, and not x, r. r0 is 0. So now let us apply the first one. So r of r is given by c1 r to the power lambda plus c2 r to the power lambda. So they are saying that if r is 0, it should become 0. But if I put r0, this gives me r infinity. Can you see that? Because if r goes to 0, this becomes infinity. So which is contradiction to our boundary condition. So that means second term should not exist. Second term should not exist. So this will give me r of r is equal to c1 r to the power lambda. Correct? Now this thing, capital theta. आवाज आ रही है भाई? हेलो?
Yes, sir.
Yes, sir. Yes, sir.
सो गए क्या भाई सभी लोग?
No, sir.
देखो इन बहुत इंटरेस्टिंग बाउंड्री कंडीशन और मैथमेटिक्स है. ये सेम चीज पोटेंशियल के ऊपर भी लागू होता है. ये ईएमटी की प्रॉब्लम बन जाएगी अगर आप नीचे वाले को जीरो पोटेंशियल पे रख दो. सेम प्रॉब्लम, नथिंग विल चेंज. द सेम यू विल गिव यू द पोटेंशियल. मैंने इसको हीट की प्रॉब्लम बना दिया है. सो फाई ऑफ थीटा is equal to a cos lambda theta plus b sin lambda theta. But phi 0 is 0, so 0 is equal to a चला गया. तो phi theta क्या बन गया? ये सब मैं कर चुका हूं ऑलरेडी, इसीलिए मैं थोड़ा फास्ट कर रहा हूं. Now apply pi. So this is also 0, so b is equal to sin lambda theta, lambda pi. So that means sin of lambda pi is equal to sin of n pi. So that means lambda is equal to n. Correct? So now what is the solution? So the solution is, multiply कर लेते हैं. When C1 will be multiplied, it will go with B and we can write it as UR comma theta is equal to summation n is equal to 0 to infinity Kn. I can write that constant like this, R to the power n sine n theta. Now it will be written like this. Now the last boundary condition will be applied. And that is, this is equal to capital T when R becomes equal to A. Now the same method, multiplied by n theta, integrate it from 0 to pi because that is the limit of theta. It will become kn 0 to pi sine of n theta d theta. We have done it many times. So it will become t minus cos of n theta by n and 0 to pi. It will become kn a to the power n pi by 2. And this will give me cos pi minus 1 to the power n, then minus, so it will give me t by n 1 minus minus 1 to the power n is equal to kn an pi by 2. So इसको इधर ले आओ, kn will become 2t by n pi a to the power n, and I can write it 4t if I just write n is equal to 1 3 5 because 2 4 6 पे 0 हो जाएगा. kn की वैल्यू आ गई है. Now we have got the solution, and that solution is ur comma theta is equal to summation n is equal to 0 to infinity. What is the value of kn? So value of kn is 4t by n pi r by a to the power n sine of n theta. So you can write it in the form of series that will be given by, tell me, r by a sine theta plus r by a cube sine of 3 theta plus dash dash dash. So this is the solution. A beautiful question. This is the solution. I can just check कि ये सही है. ये नोट कर लिया? इधर का सबने नोट कर लिया? You have noted it down?
No, sir.
नोट करो, नोट करो, आराम से नोट करो.
तो वहाँ 1/3 होगा ना?
कहाँ
r
पे?
upon a to the power 3. तो n भी तो है.
कहाँ पे? हाँ,
तो जो
1
लास्ट
by
में लिखे हैं.
राइट 1/3 होगा. So this will be plus 1 by 3. एक और टर्म लिख देता हूं. So the potential is in the form of this infinite series or the temperature. This is the temperature profile in this case. Same thing will become potential. अगर आप चाहो तो इसको EMT की प्रॉब्लम बना लो. Nothing is different for Laplace equation. एक बार नोट कर लेना तो बताना.
Done, sir.
Everybody?
Yes, sir. Yes, sir.
So I want only this part. That part will be written. अभी देखो जरा चेक करते हैं. I am going to take this point. यहां पे टेम्परेचर की वैल्यू कितनी आनी चाहिए? T? Yes? What is value of theta here? Pi by 2. What is value of R here? A. So if I put the same U of A comma pi by 2, it will become 4T by pi and 1 minus 1 by 3 plus 1 by 5 dash dash dash. देखो जरा. Correct है? R is equal to A and theta is equal to pi by 2. Tell me. बोलो भाई.
Not understood, sir.
अरे थीटा की जगह पाई बाई 2 रखो. समझना नहीं है, निकालना है. You don't have to understand it. You have to calculate it. Put theta is equal to pi by 2 and R is equal to A. I am going to calculate value at this point just to check whether this equation is correct. Cross check. So you don't have to understood it. What is sine pi by 2?
1.
And when R is equal to A, what is this value?
1.
So 1. Then R is equal to A, this is 1, and 3 pi by 2 is minus 1. So that's why minus 1 by 3. Then 5 pi by 2 is plus 1. So plus 1 by 5. Is this okay?
Yes, sir. Now it's okay.
Now this is Leibniz series. And the value of Leibniz series, I will prove this in Fourier series, is pi by 4. This is known as 1637 mein Leibniz, the great mathematician, he proved that the sum of this series is pi by 4. So what will be the value? Capital T. समझ आया? How the things work. So how mathematics and physics, they are together. You can see that at this point the value should come capital T and it is coming to be capital T. Got it?
Yes.
So revise these things. This is the extent of the partial differential equation that I wanted to discuss. Revise everything whatever I have taught in class. You will be able to solve problem in exam. Don't try to go too far because you don't have time for that. So I have touched all the aspects which are needed for your exam. So same question को दोबारा करके सारे calculation खुद करो. Don't just take it down from your copy. ये जो छोटी छोटी चीजें मैं फटाफट कर रहा हूं, आपको जब करोगे अपने आप you will feel the the friction. So that will give you the mathematical concept. Okay then, thank you so much.
Thank you, sir.
Thank you, sir.
Thank you.